Hi Cougars, this is video 3 of 3 on the Chapter 3 teacher notes. You see I am still in this last section, which is 3.7 changes of state, but I'm going to only talk about heating and cooling curves in this section. So there's, in your textbook, there's a very good explanation of heating and cooling curves. It's on page 84. And you're also going to have to combine energy calculations. And I tell students to think of this as solving the heat calculation that matches each segment of the heating or cooling curve that is in the question, and then you add up all the answers. So what I mean by that is, let me scroll down to here's an example of a heating curve. You see this is temperature on this y-axis versus heat added on the x-axis. And I don't know if you can see it, but each little segment of the curve is identified by a letter, A, B, C, D, E, and that's also written here. And what I've done here is explained which formula to use for which segment of the heating curve. And let's think about it. It makes sense because A, the temperature is changing. So I'm going to use the formula with delta T, which is change in temperature. Same thing for C and E. All of those temperature is going up as heat is being added. That means we're going to use the formula with delta T. And then the other two segments, B and D, you see we call those plateaus. And for B, that's the first phase change. And if we're going from cold to hot, which temperature here is going from 0 to some number above 0. If it were water, it would be 0 to, or below 0 to above 100. But B and D are phase changes, and we're going to use the formula associated with that specific phase change. So, for example, if this was water, let's say this temperature scale starts at negative 15 degrees Celsius and goes to 150 degrees Celsius. Section A, I'm warming the ice. It's not melting yet, but I'm warming the ice from negative 15 to 0. At segment B, that ice is now melting. And remember, for melting or freezing, I'm going to use the heat of fusion. So that's kind of a little bit of background information on the heating curve and the formulas associated with each segment. I am going to record some extra videos on problems like this because I think it can get really confusing, but it's also simple if you understand it. So please ask questions if you need to on this. I'm happy to explain it some more. There is a sample problem on page 85. It's sample problem 3.9. This problem includes segments B and C on the heating curve, and then you'll see how they solve the formula for B, they solve the formula for C, and then they add their answers up, and that's the total amount of heat needed to solve that problem. All right, and then for this section, all I want you to be able to do is identify what's happening at each segment of a heating or cooling curve. A cooling curve is just this, but backwards. Combine energy calculations by adding answers together, and define and understand phase changes and particle interactions. And that is it for chapter 3. Like I said, I am going to record some videos of me working out some problems, and I'll get those posted as soon as possible. Thank you. Hope this helps.